Welcome back. In this video, I'll be solving problem 39, combination sum. Okay, given an array of distinct integers, candidates and a target to return. Okay, this is. Hmm. Okay, this is what helps us because hmm. Oh, candidate is 2. So worst case it will be. Oh, we'll see. But this is 2 to the 30. 10 to the 9th. Okay, this will be kind of. This is a pretty hard problem. But yeah, so but this is perfect backtracking example, so I'm not sure if there is any better example of backtracking than this, because here we have take this, take this again, take well, I can take no take, and then I can take no take. So take, first I take, or I do no take. What do I do? So let me do the code. Define traverse. What will I take? So what do I need? I need combinations in any order. So I need some kind of path and index again. And well, path, index. Well, I need also target. Or yeah, I need all of these. So output so this, and what do I do? If so n is length of candidates if index is equal to, well, I don't need to do that, only if and are they all positive? They have to be positive. Okay, because if they were not positive, then this would be possibly impossible. So 2 candidates I. So if target is less than 0, I just return, and then I do take. I call traverse. Well, I add the path candidates of index. Target is less than 0 or index is equal to n. Then I return path append candidates. So I'm doing here take. So I add this. And I call two things. I call traverse of I for I in path, I for I in path, index, index, and target minus index. Well, I first put this to path. If of index is equal to target, then output dot append I think I can do it like this. Only if it's equal to the target, then I append. But yeah, but I don't want to append all the time the same thing. So path will have to be if is the same and if path not in output dot add path. Well, not append path. Path will be set. Well, can it be set? It cannot be set. No, this is too much. Well, output can be set. Why wouldn't it be set? Yes, it can be set. It can be set. So if path not in output, then I call and I just return. And if candidates of index is not equal to target, then I call traverse I for I in path, so target, so this is take, and I call it on the same index. I call take on the next index, and then I I don't want to get stuck. So if I, yeah, so I don't want infinite loop. So if I'm going back on the same index, I don't want to loop through with no take. So I want to take, because not taking 1,000,000 times and then taking 3 times doesn't make sense. I just want to take 3 times and go on. So call traverse on this index, call traverse on next index, and so path dot pop and call no take, so traverse of I for I in path index +1, again target. Put non so something like this should work. List of list. Well, I had to use set, but I will have here I for I in output. They mess up again. Okay, I think calling by reference and so on is what's making me problems here. So I have a path, candidates. On the path, I append candidates of index of candidates equal target. Hmm. Hmm. I kind of don't get it. Nothing. 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 Non-local output. What did I do wrong? So path, I append candidates of index. If candidates of index is equal to target, if path is not in output, hmm. Candidates of index. Well, nice. It's not that complicated. I haven't called a function. no word, traverse of, so empty and 0, I suppose, and target. I'm pretty silly. Unhashable type list. Well, my problem is I don't have to, it doesn't have to be a set, because let's see what happens. I'll do it. But I think this will time out, maybe. Okay, this one even works, so that's nice. And why am I missing this one? It's pretty interesting. What's the exactly reason why do I miss 12, 4, 4, 4? What? Because if I'm using this index, what? Why am I missing that one? It doesn't make any sense. This doesn't make any sense. So I haven't taken anything. So imagine I'm here and still haven't taken anything. I'm here and I'm here. Well, whatever. Well, return or if index is equal, and I'm not sure what happened here. I had to do take. Seems like an edge case, so if index is equal to n, I just return, and if so I can keep this, or maybe not. If index well, I take it. What happens? So I have all threes. Why wouldn't I not have all fours? If target is equal 0, well, I can do this. Maybe some and return. Well, just return. Okay, too much to do threes now. Hmm. Well, yeah, I have to do if path not an output for sure. If this doesn't, it still doesn't work. What? I don't understand this. This is beyond me. I'm just trying to make sure everything's okay now. Right? Went too far back. Okay. So why this doesn't? Oh, why this does not work? So I'm missing the last one for whatever reason. And when I called this one, so for I prime path index target candidates minus index, I call this one on the same index. I will call it again. So with index last one, and if target is less than 0, it's not, or index is equal and it's not, I'll not return here. Okay, I get it. I get it. The last time I'll, well, but last time I'll call it, it will be 4. Now we'll add it. It doesn't make sense. So let's imagine first time I call it, I decide to call it. It's target minus candidate, so it's 8 first time. And I killed this one off, and I killed this one off. I call it again. This is not true. Maybe path is an output. I really don't get it because this one works, so well, I should try this infinitely. Path, hyperline path. Well, I can print path just to check if it's in it. What am I doing? That's the problem. Okay, let's run. So I tried 3. What is this? And then I tried 12. Why is it cut off? Something is pretty weird here. So it gets cut off. Maybe the... So I try nothing. I try 11. Where did I print this? On the call. So it seems that I never called 11. I called 11 with everything. With 6. 11 with 11, 11 with 6, 11 with 5, with 8, 11 with 3, with 12, with 7, with 4. Maybe it's this problem. But if I'm doing no take on the same index more than once, there is no use in doing no take. There is no use in doing this. Hmm. Hmm. This is really beyond me. So, but I don't see that it ever tries to do. So 6, 5, 8, 3. And then it's that. So I tried nothing. And then it's tried 12. So it tried nothing. It's interesting that it stopped at 12. Because with 12, but I append. Oh, I get it. I get it. I should have done no take first. That's the problem. Okay, this one was pretty specific. Because problem is, yeah, should not. Well, I should kill it off, but I first need to traverse past it. So yeah. Okay, pretty interesting. This was, well, this was efficiency-wise pretty bad, but interesting problem. Interesting problem, yeah. And perfect example of backtracking. So if you want to learn backtracking, this is perfect example. Do I want to optimize this? Well, possibly not. What I could optimize for is this. So this will be In the last video I was pretty bad with whoa. Yeah, I shouldn't have popped here. Will this help it a bit? Nah, same thing. What I can surely optimize is this comparison, I think. Time complexity, space complexity. And how would I... Well, if I used it as a set, well, I need to remember the path, but is dictionary hashable? Well, not sure. Yeah, I'll optimize next time. As I said, I got caught a bit in thinking about it, but let's see. So this take, no take, for each call, well, should be n times but this is only if it's possible answer. Yeah. Oh. So all three, something like this. Space complexity loss should be same. Let's check what this says. Server busy. Exponential primary due to storing all combinations. Okay, yeah, probably can be optimized with yeah, it can be optimized. Due to redundant calculation. Okay, nice that this provide me feedback, but I just wanted yeah. Well, as it said, it's not pretty efficient solution. Maybe I'll do optimal one next time, but I think this is the complexity for it. Yeah. Okay. That's all I got for this one. If you have any questions, leave them in comments. And yeah, I appreciate you following this one and see you in the next one.